Good morning everyone. I am Prashant Shirgavi. Today I will be presenting on the topic KNN basics and how to choose the best value of K. KNN is one of the simple and most popular algorithm in machine learning. In this session, we will look at the why it is useful, how it works, its challenges, and finally with a short summary. So, why KNN? KNN is considered one of the easiest algorithm to understand. Unlike many machine learning method, it doesn't involve complex mathematics or heavy training. Instead, it works by comparing the distance between data points. For example, think about fruit. If you see a new fruit, how do you classify it? We compare it with fruits that you already know. If it looks most similar to apple, you can tell it is an apple. That's how CNN exactly works. It looks at the closest known data points and assign a new one to that group. This simplicity makes CNN very practical for both classification and regression problems. Now, what is KNN? KNN stands for K nearest neighbors. It is instance-based learning algorithm. It means it doesn't create a separate model during training. It simply stores the dataset. When a new data point arrives, it looks at the K nearest neighbor and decide based on them. A real life example. Suppose you want a movie suggestion. You ask your K closest friends. If most of say movie A, you probably choose a movie A. That's exactly how KNN make predictions by measuring the votes. Some important points to be remembered. KNN is a lazy learning. There is no training step. Predictions happen only when needed. It is a similarity based. It uses Euclidean distance to measure the closeness. So, in simple word, KNN use nearby data points to make the predictions. Now let's talk about the most important factor in KNN, the value of K. K represents the number of neighbors we consider while making a predictions. Since every decision depends on this, choosing the right value of K is very important. Let's understand with an example. Suppose we have a new data point, which is a question mark. Simply, we need to predict whether it's belong to rectangle category or the triangle category. If we take K3, the three nearest neighbors are two rectangle and one triangle. That's why the majority is a rectangle. So new point is classified as a rectangle. But if you take K7, among the seven neighbors, there are three rectangle and four triangles. So the majority is triangle. That's why a new point is classified as a triangle. That's why see how the prediction changes when the change in the value of K. That's why choosing the right value of K is very important. There is a simple rule to select the value of k. Simply take the square root of the total numbers of data points. For the given example, there are 9 data points, that's why the right value of k is 3. Always we select an odd value of k to avoid the ties between the classes. Of course, KNN also has limitation. First, it doesn't scale well to large datasets. For every prediction, it has to calculate the distance to every single points, which makes it slow. Second, it's sensitive to outliers. Noisy and unusual data points can easily mislead the algorithm. Third, it struggles with the missing values because distance become unreliable when the data is incomplete. For example, if you try to predict a pass or fail for the thousands of students, KNN will be slow, and if dataset has missing and wrong entries, the accuracy will also be dropped. To summarize the today's session, KNN is a simple and easy to understand algorithm. It makes prediction by looking at the nearest neighbors. The accuracy highly depends on the choosing the right value of k. It works best for small, clean datasets and clear pattern, but it can become slow and less reliable with a large and noisy datasets. So, overall, KNN is a great starting point in machine learning. Simple and effective when used with the right data.